Hello everyone and welcome to a new tutorial on code-aster and Salome Meca. In this tutorial we are going to see very new features of Salome Meca 2019. So let's start with the actual tutorial. We are going to see three new features which are Shaper module, wizards or also called as assistants, and post-processing or results tab. These three are included only in 2019 version. Before this, that is 2017 and 18, these three were not there. So let us now continue with each one of them. First one is Shaper module. This is kind of an alternative or assistive to geometry module. I say alternative to or assistive because some tasks can be done completely in Shaper module and you may not need geometry module at all, while for some tasks you may need to have geometry module after using Shaper module. So that's why it is either alternative or assistive to geometry module. And the workflow of Shaper module is very similar to FreeCAD. So if you already know FreeCAD, you have used FreeCAD, then you just don't need to bother about what the Shaper module is. However, the FreeCAD is much more sophisticated at this stage, and Shaper lacks some of the features of FreeCAD. And I hope that as the time progresses, Shaper will catch up with FreeCAD very soon. The second feature that we are going to see is Aster Study Wizards, or also called as Aster Study Assistants. These wizards were earlier available in Salome Meca, that is prior to 2017. These wizards were available. However, in 2017, Salome Meca introduced Aster Study Wizard Salome Meca introduced Aster Study, and wizards which were earlier present in Salome Meca were not compatible with the new module of Aster Study, and that's why the wizards were removed temporarily. But now they have made a comeback in Salome Meca 2019. This is very good news for beginners because wizards make things much more easier, and the simple studies can be executed very quickly with merely a few clicks, which we are going to see now. And this is also good for experienced users because experienced users can now get the basic structure of their study done very easily using one of those wizards, and then tweak the study as and when required. So that's the Aster Study Wizard that we are going to see. And the third modification that we are going to see is post-processing or results tab. This is nothing but a simpler interface for common post-processing tasks. This, at least to me, the results tab has a much better visualization than what we had earlier in Paravis, that is if we consider the defaults. And if you are still interested in Paravis, and if you have some sophisticated work which still needs Paravis, then that post-processing module is still available and you can use that Paravis module as well. So now to introduce these three tabs, these three new features, instead of just explaining about them, I thought that I will take a problem and try to explore the features of them, so that you will get the idea of workflow as well, the entire workflow as well. To do that, I have chosen this simple problem of modal analysis of a beam. This is a cantilever beam, and you can see this is the section, this is the top view of the beam, and this is side view. And you can see the length of the beam is 3 meter, width of the beam is 250 mm, and depth is 50 mm. And this portion is cut out from the beam throughout its length. So this is kind of a hollow beam. Moreover, you can see there are two holes which you can see in the top view as well. So these holes are of 50 mm diameter, and other details you can see over here. Moreover, the material properties are similar to steel, rho, Young's modulus, and Poisson's ratio. You may ask why you have chosen this kind of problem. There is nothing specific about this problem. Only reason is I wanted to explore some of the features, the new features, and I found that I can explore many features if I choose this kind of geometry details. So that's why I have chosen this. There is no other purpose. Okay, so let us start with Salome Meca now. If you open Salome Meca 2019, the first thing that you will notice is that it says in the tooltip it says 2018, as well as here in title it says 2018. So how to ensure that it is 2019? First thing, on this line, modules line, if you see on this second module, it is SHAPER module. So if SHAPER module is present, then definitely you can say this is 2019. Another way is just go to help, about, and then modules information. You can see Aster study 2019, as well as SHAPER is also available, you can see here. So this confirms that it is indeed 2019 version. Let's start with SHAPER directly. So in this SHAPER, the window is very similar as you can see for all other modules. In the left side, in the object browser, you can see you have part set. That means you can have multiple parts and then create a set of those parts. So that's why it is part set. And in that you have three different sections. One is parameters, then constructions, and then parts. And only in constructions you see this 7 number. So just expand this and you will see what are the various constructions available. These are by defaults: origin, x-axis, y-axis, z-axis, and then planes. These parameters, for my understanding, I call them as global parameters because these parameters are for part set. Whereas for each part also you can have different parameters. So that those I call part parameters or local parameters. Now we want to create geometry first, or like sketch we want to create first, and from that we have to move to geometry. So to start with, you can see parts are 0. If you right click over here or double click, nothing happens, and that's actually a basic problem right now. Only way you can move ahead over here is go to part and create new part. As soon as you create new part, click on new part, you can see part 1, and in parts you have this one, so that part is there. So in part set you have this part 1, and the details of part 1 is here, and again within part 1 you have 3 sections: parameters, constructions, and results. In the parameters, again if you click right click or double click, nothing happens over here. Only way you can add parameters into this is again go to part and go to parameters, and here you can give parameters. I will give 3 parameters right now, that is length is 3 meter, then width, that is b, width is 0.250 mm, and depth is, now notice here it is set as expression. I was giving values here, but you can also give expression. Just to emphasize that, instead of giving it as 50 mm or 0.05, I can also give it as b divided by 5, and it will automatically calculate the value because b by 5 is 50 mm. Okay, so these are the parameters. The reason I have given parameters is that in SHAPER you can parameterize your geometry. We will see how to do that as well. So now we have parameters. Let's start with constructing our geometry. So go to first primitives and create a box. This should be length L, width B, and depth D. And just click on this tick and zoom in. You can see this beam is created. Now on this beam this beam need to be hollow, and not this specific hollow is specified here, that is the cross section of that hollow portion is like this. So I need to create this portion over here, and then I need to cut entire beam using this portion. So to do that, what I will do is click on sketch, Now what it says is select a plane on which to create a sketch. So there are many planes, that is basic principal planes are also there, as well as each surface can also be treated as a plane. So now I will use this as my plane because I want to create something on this. So this, as you select this, you can see the color of this plane is slightly changed. It is greenish, whereas this is grayish. Click on set plane view. Now that small plane is this entire white plane here. Let me just rotate it and you can see. Yeah, so this was the plane that I had selected. If I click set plane view again that plane is over here. Okay, so now let us start creating the sketch on this. I need a sketch of this shape. So therefore let me draw it. And what are their dimensions? I am not bothered at all at this stage, and I didn't even close this. Now I have completed this, I will say escape. Now these are not at all closed, but I know that it needs to be closed, and moreover these dimensions are specific, that is this need to be at 25 mm distance, this point, and then this point need to be at 5 mm distance from top, and so on. So there are many constraints that this shape need to follow. So I will do that. First thing, I need to ensure that these 2 points are collinear. So this line is very important. Now this is like constraints. I have to apply the constraint to this object. And also notice that the drawing right now is red, the sketch right now is red. We will see what happens to it later on. First of all, just check this one. The tooltip says coincident. That means 2 points can be made coincident using this particular constraint. So just click on this. On the left side you see first object and second object. Choose first object. It is chosen. Choose second object. Done. They are automatically coincident now. Click on OK. Other than that, now I need to make sure that all these lines are of equal length. So from here I will see this one, that is equal, that is equality constraint. Click on this. First object, second object, first line, second line. Then again I can choose first line, that is this one here, and then second line. These two are equal, and then I can choose again this and this. So all 4 lines are now equal. Done. So this is how I have chosen equality constraint. Still it's not enough, because now I need to ensure that this point is at a proper distance from horizontal and vertical end. To ensure that, I need distance. So first object is this line and second object is this point. And what should be this distance? Just make these dimension lines outside, click on it, and here you can put that distance. This distance need to be, this is 25 mm, so it is 0.025. Enter. And that's it. Then I also need vertical distance. So that is from this line to this point. And this vertical distance, click. This can be parametric now. Means all these dimensions can be parametric. So here I will give that parametric. I know that depth is d, so this has to be d by 2. So I will give d by 2. So far it is okay. This point is fixed. Still you notice this one is still red, nothing is changing. Fine. Now I have a few more distances to cover, so I will do it. This point to this line, this distance has to be 5 mm. Similarly, this distance has to be also 5 mm. is still red, so something is still missing. Once everything is correct, all constraints are applied, then this is going to turn into green, but still it is not green, so that means something is still missing. So let us see. Yeah, this point is 5 mm, so either angle or length I need to, okay, fine. So from this point, sorry, from this line to this point, this distance is half of width, so b by 2, that's it. And now it is green. This means that everything is perfect. So far it was red, that means there was some problem. As soon as it becomes green, now it is usable, you can proceed. So now click on OK. Done. So you have this sketch on this, only this sketch is only on that particular plane, that particular surface. Now I want to cut through entire length, so just click on sketch 1 and here extrusion cut. Extrusion cut, these defaults you can keep, what way you want to cut, and then in each direction, because this is on this surface, it will have two directions, one on the other side and one on towards me, or you can say into the screen and out of the screen. So that also I can define, and that also can be given in terms of parameters. So since the length is L, I can give that on both sides. I will say L, doesn't matter, and cut from, click on this and just choose the object. You can choose from here as well, but since the object browser is much below here, it's not possible easily to click on that. So just click on this object. So box 1, we want to cut it from box 1, and then click apply. That's it. So now you can see that entire length is cut now. So zoom out and rotate, and you can see the entire length is cut. And that's it. Very nice. Now similarly, I also want to create these two holes. So let's go to creating sketch again and select this top surface and set plane view. Now create circles, two circles, 1 second, and again I don't need to bother about where they are right now. Done. I will set equality constraint in between them. Okay, now I need to provide their radius. Now once I give radius to 1, it will automatically be updated for the other one, because I have set equality constraint. Now here, this is radius constraint, and what should be the radius? The diameter was 50 mm, so radius is 25 mm. So second one automatically changed to 25 mm. Another thing is, I need this to be at the center line and at 1 meter distance. So that also I need to do. And to do that, choose the distance, and this distance has to be b by 2. Similarly, and this distance has to be 1 meter, or I can set it L by 3, and I can set either distance between these two or from the edge. So I will choose that. That's it. Now you can see both are green, and done. Now choose this sketch 2 and again extrusion cut, and D, depth, cut from this. Done. So now if you rotate it, you can see the geometry is done perfectly. You have both the cuts. Perfect. Now all I need is create groups from the extrusion cut. This is the final shape, and here I need to create groups. So group and group of faces. Choose this face. Fix. That's it. I need only one group right now because there is this is model analysis, so no loading or any other kind of constraints that I need. Now once that is done, then click on extrusion cut 2 and go to features and export to geom. That's it. Now it is exported to geom. Go to geom module and you will see in the geom module this is extrusion cut. This is available. I don't need to do anything here, just expand it and you will see the group is also available directly. So you don't need to do anything over here. For some cases you may need to. Right now you don't need to do anything. So just go ahead and go for mesh. In the mesh module, mesh, create mesh, and I'm going to choose the simplest one, that is NetGen 1D, 2D, 3D and default parameters. And compute. Mesh is computed. Now just I need groups into it. So mesh, create groups from geometry, choose it and done. So you have mesh ready. That's it. Now go to Aster study module. In the Aster study module, instead of add stage, you just go to add stage with assistant, and this is what is wizard, the second thing that I want to introduce. In this you can see there are multiple wizards, linear, thermal, isotropic linear and so on, of which modal analysis is the one that we need. So click on modal analysis. This gives you the wizard. This will create simple modal analysis. So just click on next. Specify input mesh. Since it is created in Salome Meca, you can use it directly, or you can use file. You can browse that and you can use that made file. Mesh 1. Next. What kind of model do you want to work on? There are 4 possibilities: 3D, plane stress, plane strain and axisymmetric. Right now it is 3D. Then Young's modulus, density and Poisson's ratio. It is 7850 I said, so I will use that. Provide those values. Next. Now boundary condition. Add boundary condition. Fix 0. That's the only thing that we need. Next. Criteria for eigenmodes. Whether you want n first eigenmodes, frequency band or frequency centered. If you have done modal analysis before, then you know various kinds of eigenmodes we can search. Right now I need first 10 eigenmodes, so that's what I will give here. Next. And specify output result file. So just choose browse and some appropriate result file, that is modes.rmed. okay, that is already there. Save and let it replace. Finish. Now you can see the entire study is populated here. You don't need to do anything over here now. This is done. So just save this study and save it as maybe say modes.hdf, and now go to execute it. Here this square is on this red button. Just click on this so that it will be on green button and then click run. this graph is right now not usable, but I think for nonlinear analysis it will give some information, maybe convergence or something. I'm not sure, I have not used it yet. Maybe sometime later we will explore that. That's it. So now run case 3. This is executed and we have a green light here. That means everything is perfect, no problem at all. Now since the execution is complete, so morse.rmed file is generated. Just right click over here and click on post process and nothing happens. This should not be the behavior, maybe some bug or something. So here, even though the results are available, now results tab which is available here, it is still not active. So what you need to do is go back to case view and here morse.rmed, right click over here and click on post process, and now it works. Moreover, one more point I need to mention here is that this is actually time taking, because this loading of this post processor takes significant amount of time. So I think that also can be improved in later stages. And I don't know what is the weird reason behind this, but every time this goes below, this window goes below, so I just need to double click and get it back. Okay, anyway, so now results tab is available, and in the results tab you see this nice window. I personally find it much more appealing than earlier post-processing default views that we had. Now in this you can see there is something like shadow, and then this is actual beam, and the beam is what we had earlier. You see these cut sections are there, and this shadow indicates the original configuration or undeformed configuration. You can toggle that using this button. That's it. So now this is first mode, and you can see you can change various things. Component instead of magnitude, I will choose DZ because the modes are in DZ, and you can see what is the DZ value, but let me keep it magnitude for the time being. Okay, now you have frequency of 7.09 Hertz. Go to next one and you see frequency 27, and this is it in Y direction. Next mode is like this, then so on, fourth twisting, and then in Y direction, Z direction, and the last mode is something like this. I think it is axial mode. Yeah, last mode is axial mode. Yes. So now let's go back to first mode. This is the first mode. We can see from the original configuration as well as the deformed configuration. However, since it is mode, it would be better if we can animate it, and to do that just go here DEPL and right click animate mode, and you can see the animation. Now if you want next mode, just click next and it will start the animation. If suppose you want next one, go for the next one, and that's it. So this is the results tab. You can play around with various options over here. You can change the number of periods or frame rate. Instead of 2, if you do 5, click on apply and play, and you will see it will happen 5 times. Similarly frame rate and so on, but it is not advised to increase the frame rate beyond this, because then for a large problem your system may not work properly, or in the sense the memory or the processing power may not be enough to handle that kind of frame per second. So therefore keep it right now as it is, or if suppose you have big model, just reduce it to 5 or 10 frames per second. That's it. So we introduced 3 things, that is shaper module, wizards, and post processing or results tab. That's it for now. Hope you enjoyed, and see you soon.